In the right triangle ABC, we have A is the 90 degrees angle, and we have here CB is the hypotenuse, and AB and AC are the right sides of the triangle ABC. So how to define the trigonometric ratios of one of the angles of the triangle ABC? So in our case, we will try to define, or will define the trigonometric ratios of the angle B. So here, the sine is defined like the opposite divided by the hypotenuse. So the opposite of B is actually the side AC, so this. And the hypotenuse, of course, is this one. So in this case, we can write sine B is B divided by A. And cosine B is the adjacent of B, which is this, C, divided by the hypotenuse, A. So it's C divided by A. And the tangent is actually the opposite divided by the adjacent. So here we have the opposite, and this is the adjacent. So in this case, tangent is B divided by C. Cotangent B is the adjacent divided by the opposite, so C divided by B. And if we give links to the sides of the triangle ABC, for example, if we say that B equals to 3, C equals to 4, and A equals to 5, then the answer will be sine B equals 3 divided by 5, and the cosine is 4 divided by 5, and the tangent is the opposite divided by the adjacent, which is 3 divided by 4, and the cotangent is the adjacent divided by the opposite, which is 4 divided by 3. We can also say like the cotangent is actually the reciprocal of the tangent, which means if the tangent is 3 over 4, so it will be 4 over 3. And in the right triangle, actually, we have Pythagoras theorem is always applied, which is a squared b squared plus c squared equals a squared. And for the numbers that we give to the lengths of the right triangle, if we calculate them or substitute them in Pythagoras theorem here, or Pythagoras identity, we can say b squared it's 9, c squared is 16, and this must equal a squared, which is 25. And in this case, Pythagoras theorem is satisfied, which means also like we have a right triangle here. If we take Pythagoras identity, b squared plus c squared equals a squared, and divide both sides by a squared, we get b squared divided by a squared plus c squared divided by a squared equals a squared divided by a squared, which is 1. But here we have b squared divided by a squared is actually sine squared b, because b divided by a is the sine. So we can substitute and we get sine squared b plus c divided by a is actually the cosine in this case. So in this case is cosine squared b equals 1. So we get the identity that contains the sine and cosine, which means like if we know the value of sine, we can calculate the value of cosine of the angle, and vice versa. So if we know the cosine, we can calculate the sine. So it's always satisfied that sine squared b